Okay, so let's go ahead and take a look at this lesson. So this lesson is going to deal with definite integrals again, but what we're going to do is instead of looking at the area under the curve, just one curve with respect to an axis, we're actually going to look at the area between two curves. So finding the area between two equations. And so if I'm given this figure 7a here, and I wanted to find the area of this shaded region, what I'm essentially doing, and my graph is off just by a little bit, so we'll fix that, is we are, make this part white here, we're finding the area from the intersections of f of x and g of x. We're finding this entire area under the curve with respect to the x-axis. And then we are subtracting off this shouldn't have been shaded in. So we're subtracting off this shaded region here, this little trapezoid. And that gives us the area that we wanted, which was above here. And so common terminology that we normally talk about is we talk about finding the area under the curve as the top minus the bottom. So the top equation minus the bottom equation, or depending on the perspective, it could be the right equation minus the left equation. And when we look at this, top minus the bottom means the top equation has the more positive, most positive y values, and then the bottom equation has the most negative y values. Okay, so let's go ahead and take a look at an example here. So this first example that I have has the graph of a straight line, and it has the graph of a parabola, and I want the area between the two curves. So the first thing we're going to do is we're going to find out the intersection points. So I want to find out these intersection points above and below down here. And when we find the intersection points, we actually can find both the x and the y values. So you can do this with your graphic calculator, which I will show you in a second, or you can do this with your paper and pencil, or you can do this with Desmos. So let's take a look. If I did this by hand, which is what we would normally have done without a calculator, I would take these equations and I'd set them equal to each other. And then I would make one side 0. So x squared minus 4 is equal to 0. So x is equal to plus or minus 2. So that gives me the values of x. My equations are in terms of y equals, so y is what's isolated. So I'm going to be looking at top minus the bottom. If I draw a line through my shaded region, my top equation would then show me that my g of x is my top equation, and my bottom equation is the parabola. And so to find the area of the shaded region, I would take the top equation, which is the 2x plus 5, and subtract off the parabola. So that means that area is equal to the antiderivative from negative 2 to 2, 2x plus 5, minus my parabola, which is x squared, plus 2x plus 1, and dx. Now, because this is these are polynomials, you can find you can simplify this and then find the antiderivative by taking adding 1 to the exponent, multiplying by the reciprocal. So these questions that you guys are going to get, you can get some on the multiple choice, but primarily this shows up on free response. And when it shows up on free response, it's typically a calculator question. However, something like this, where it's just polynomials, can show up on a non-calculator portion. And then they would expect that what you would do is you would take your, so that's 2x and minus 2x, so those cancel out. 5 minus the 1 is positive 4, so this would be the antiderivative from negative 2 to 2 of 4 minus x squared dx. So then you would take your antiderivative, so 4x minus 1/3 x cubed, and evaluate this from negative 2 to 2. And then when you do this, you get, and I have it in the decimal form, which is 10.667. So let me show you how to do this with your graphic calculators, okay? With your graphic calculators, when you do your integral and you get a big decimal, you must make sure that you round to 3 decimal places. Not 4 decimal places, that's wrong. Not 2 decimal places, that's also wrong. 1 decimal place, wrong. No decimal places, wrong. Has to be to 3 decimal places and 3 decimal places only. That is College Board's rule. Okay, so now we're going to take this equation here, and I'm going to I know you guys have done this in a previous class where we've taken the graphing calculator and we have figured out, you know, what the intersection is between f of x and g of x. Okay, but I want to go through it one more time just in case you guys have forgotten. And then what we're going to do is I'm going to show you how to find the definite integral. Okay. Okay, so now I have the graphing calculator shown here. So the first thing I'm going to do is I'm going to plug in my y equals, which is variable x squared, and then plus 2x, and then plus 1. And then we're going to scroll down and we're going to do 2x and plus 5. And then we're going to hit graph. And you're going to see your graph which matches the graph that was on the page. And you'll see this right here is your shaded region. So now we're going to find the intersection points, which is second, the trace button, which is calc. 5 is intersection. First curve, hit enter. Second curve, hit enter. Guess, and you're going to scroll close to the intersection point that you want, which will do the top one. And you hit enter, and you get 2, 9. So it gives you both the x and the y value. To get the other intersection point down here, we're going to do it again. So second, trace. 5 is intersect. First curve, enter. Second curve, enter. Guess, we scroll down towards the other intersection point and we hit enter, and you get negative 2, 1. Okay, so those are my 2 intersection points. That's how you find intersection points. Now, how do we calculate the definite integral? So we go second, quit, and you go math, and when you scroll down to what's called fnit, and it's function numeric integral. So you hit 9, or you scroll down and hit enter, and it shows up with your definite integral. Now, if by some chance your calculator shows you with f and int in a parentheses, I'll show you just a second when we go back to the other screen how you can type it in. Okay. So we're going to go negative 2. And then we'll go up. Make sure you use the negative symbol down here and not the subtraction sign. Otherwise, you'll get the wrong answer. And then you're going to scroll to the right. Now here, I don't want you guys plugging in the equation. Okay, so it'll take you forever to plug in the equation. And when you do that, if you plug in the equation, I would say that you're going to have major calculator issues, because your graphic calculator thinks it knows order of operations better than you do. And so if you don't put parentheses in the right spot to do order of operations correctly, then your calculator thinks order of operations in a different way, and then you get wrong answers. So the easiest thing to do is, remember, we plugged in into y1, we plugged in our parabola, and into y2, we plugged in our straight line. So we're going to go what's called vars. So we're going to push the vars key, We're going to scroll to the right. Function is listed first. We're going to hit enter. And what you notice is that you see y1 and y2. Well, which equation's on the top? Is it my parabola or is it my straight line? You can kind of see it right here. My straight line is on top. My straight line we plugged into y2, so you put enter on y2. Minus, go back to vars, scroll to the right, hit enter on function, and we go to y1 because my parabola is in y1. You scroll to the right, your variable that you're integrating with is x, so you hit enter with the x. I'm sorry, you hit x, and then you hit enter, and it gives you 10.66666 repeating. So basically 10.667, okay? And that is the area that I told you was the answer in the previous part, okay? So now let's go back and I can show you if by some chance you don't get this integral and you get this f nint written out. Let me show you again what it looks like. If you end up with this f nint and the parentheses instead of the integral, then I can show you how to plug it in, okay? So if by some chance you get f nint and a parentheses, then you're going to go and plug in, and it was y2 that comes first, minus y1. You're going to put an extra set of parentheses around there. Then you're going to go comma, x, comma, -2, comma 2, and hit enter. So your integrand comes first, then your variable of integration, then your a value, then your b value. And you get this integrand from doing your vars again, okay? And so it will still work. It just, will have to look like that instead. It's very important, though, with your solutions that I need to see you finding the intersection points. I also need to see this integral for you to receive credit. Not this one, the actual integral with the equations in there, and then I need to see your answer. So I need to see all three of those in order for you to get credit, okay? So let's take a look at another example. So find the area bounded between the two graphs of your upside down parabola and the straight line y equals x, okay? So I have the graph here. I will tell you, you will not always get the graph, okay? So it is important that you know how to plug your graph into the graphing calculator. Now, I went ahead and I found my intersection points, which are right here below and right here above. I found them by hand, but again, you can plug these both into y1 and y2 and then do the second calc, intersect, and find the intersection points that way. But when I do set my equations equal to each other, I get x equals -2 and +1. Which one's on top? My f of x is on top. Remember when I draw a straight line between them? This is my top equation, and here's my bottom equation. So my g of x is on the bottom. So I plug in my f of x first, minus my g of x, and I'm going from -2 to +1. And then when I calculate this integral, either by hand or by using my graphing calculator, I get 4.5, okay? So now what happens in a situation where my graph, top and bottom equation change somewhere? Well, that just basically means that you need to write two separate integrals. So we're going to deal with my left side first, and then we will go and deal with the right side. So to find intersection points, because these are polynomials, I can find the intersection points by hand. So I set it equal to each other, 3x cubed minus x squared minus 10x. If I'm letting you use a calculator, you are more than welcome to do this using your graphing calculator instead of by hand, and you would still receive credit. So I move everything to one side, so I get 3x cubed minus 12x is equal to 0. So factor out a 3x, and I'm left with x squared minus 4 equal to 0. So x is negative 2, 0, and 2. Okay, so again, notice between, on the left-hand side, my f of x is on top, and then my g of x is on the bottom. And that is between x equals negative 2 and x equals 0. And then it switches, and between x equals 0 and x equals positive 2, my g of x goes on top, and my bottom equation goes to f of x. Okay, so I will need two different integrals. My area is equal to, my first one, negative 2 to 2, and we are putting f of x on top. So 3x cubed minus x squared minus 10x and then we're subtracting my g of x equation, which is negative x squared plus 2x, and then dx, and we are adding this to when it switches, and this should not be negative 2 to 2, it should be negative 2 to 0. Okay, and then we're going from 0 to positive 2, and my negative x squared plus 2x comes first because that's on top, minus my 3x cubed minus x squared minus 10x goes on the bottom, dx. Okay, when you evaluate both of these integrals, and you can do this in one of two ways. Probably the easiest thing to do is if I'm letting you use a graphing calculator. You could have in the very beginning plug this into y1 and plug g of x into y2, and then use your vars. And when you do that, you would get an answer of 24. Okay, you could do this by hand and you would still get 24 as well. So it's completely up to you guys. This can show up on the non-calculator. It can show up on the calculator. I typically will test you guys on a free response using a calculator. So you're more than welcome to do that for all the problem sets, but just know on a midterm, a final, or your actual AP test, I could have you guys do this without a calculator, because this particular example is a polynomial that you can easily take the antiderivative of, and you can easily find intersection points. Okay. So now let's take a look at the next example. So now, one more little example, and now it's kind of a sideways parabola and a straight line. Okay, so how this is different. This is different because what happens is now my x equation is isolated, and so I have this, parabola and this straight line. I can find intersection points the same way. I can set my equations equal to each other and solve, so I get negative 1 and 2 are my y values. The way this changes is that inside the integral, the integrand, are going to be y variables, and then you're going to integrate dy. Okay, now it is, how it also is different is I'm going to look at my rightmost equation minus my leftmost equation, because my area is going with respect to the y-axis instead of the x-axis. So my integral is actually going to be area negative 1 to 2 of my rightmost equation, which is y plus 2, minus my leftmost equation, which is y squared, and this is all dy. Okay, now this is a polynomial. I can easily take the integral and plug in the values, but I want to show you guys, your calculator only likes to deal with the independent variable being x. So anytime you change that independent variable to be something else, it sometimes has problems processing. So what we do is we go ahead and we trick your calculator. how we trick your calculator is, remember, variables are a placeholder. So it doesn't make any difference whether or not it's y for your graphic calculator or if it's x. So what we're going to do is we're going to pretend we have the equations in terms of y. We're going to pretend that they're x variables. So let me show you with your graphing calculator. Remember this equation here. Okay, so you remembered your equations, right? So it was y plus 2. So we're going to plug in x plus 2 instead of y plus 2. So all I did is I just switched my variables for y with x. Okay, and then instead of y squared, we're going to put x squared. Now I'm not going to hit graph because it won't show the right graph. But now I'm going to go second quit. I'm going to go to math. And then what's my integral? 9. And I was doing the integral from -1 to 2. And it's your y plus 2, which is in your y1, minus vars, scroll to the right, enter, and then y2. And then I'm going to plug in dx, because remember, I took all my y's and I put x's now. And then I hit enter, and I get 4.5. If you were to do this integral by hand, you would get 4.5. Okay, so now let's take a look. Let's go back. So what I said is that you're supposed to get 4.5. If you don't believe me about the integral, let's just do it real quick. -1 to 2. This is 1/2 y squared plus 2y minus 1/3 y cubed and dy. And we're going to not have the integral symbol, not have the dy. And we're going to evaluate, from -1 to 2. So I took my integral, so I had to get rid of that integral symbol. So I have 1/2 my y squared, so 2 squared plus 2 times 2 minus 1/3 times 2 cubed. And I am subtracting off 1/2 times -1 squared plus 2 times -1 minus 1/3 times -1 cubed. Okay, so I get 4 divided by 2, which is 2 plus 4 minus 8/3 minus 1/2 plus 2 and minus 1/3. So now this gives me 6. No. This gives me 8 minus 9/3 and minus 1/2. So 9/3 is 3, so this is 5 minus 1/2, which is 4.5, which is 4.5. Okay, so I do get the same answer. So just remember, variables are placeholders. Anytime you have something in terms of y, I can replace all my x's and my y's. I'm not resolving. I'm just replacing all my x's and all of my y's with x's in my graphing calculator to trick it to give me the actual result. Okay, and that is it for this lesson.